All right, number one. And hopefully we all get number one right. This one gives you the radius. So I use 2 pi r. 2 times 13 would be 26 pi if it was to be left exact. So again, it will either say exact or in terms of pi, and that's what it means. Leave it like that. Or it will say round to whatever decimal place, and I would then do 26 times pi in the calculator, and you'd get 81.7. Uh-oh.
I got 81.6.
Oh, just watch your rounding, because that would stink to lose points on something like that.
Uh-oh.
All right, second one is now you want to find the radius, and you're given the circumference. So again, circumference equals 2 pi r. This time I have the c, so 48 is c. Divide both sides by 2 pi. Exact and in terms of pi would be 24 over pi. And then actually putting that in the calculator to do 24 divided by pi, you should get 7.6. Questions on that one?
Nope.
Okay, then came the length of the arc. So this is the formula for the length of the arc. It is the measure of the arc over 360 times 2 pi r, or times c, or times pi d, because all of those are interchangeable depending on the information you're given. This time they gave me r, so I used the long one. 55 is the angle, which means it would be the same as the arc. So 55 over 360 times 2 times pi times 9. Now I want to simplify this any way I can. So I can do 2 into 360 would be 180 times. I can do 9 into 180, and that would be 20 times. I can do 5 into 55 and 5 into 20. And my most simplified form is 11 pi over 4. That's if it said, and it would be centimeters, if it said keep in terms of pi. If it didn't and it said to round to the nearest tenth, you could literally go from the beginning and multiply all the numerators together, 55 times 2 times pi times 9, and then divide by 360, and you'd get 8.63, which is 8.6 when rounded to the nearest tenth. Or you could do 11 times pi divided by 4 and get the same answer. If you didn't have to reduce it, then I would not have spent the time doing any of that stuff. I would have literally multiplied straight across. 5 times 2 times pi times 9. So like if it says to just use your calculator, make it easy on yourself and just use a calculator.
I got 2.75 pi.
What? Oh, you want to keep it. You want to keep it in terms of the fraction. That's the easiest way to keep it. 2.75 is still exact, so it's okay. But if let's say that was 11 over 3 and you rounded it, now it's not exact anymore. So that would be wrong.
Okay.
So it's easier just to leave it in the fraction.
I got 55 pi over 10.
That can be reduced. Yep.
I got 11 pi over 4.
It should be 55 pi over 20 then.
Yeah, so that
No, because I multiplied the 2 and the 9, I got 18. And I divided the 18 by the 180.
What happened? It should be 360. If you did 2 into 360 to get the 180, now it's 9 into that. Yeah, you did it twice.
Okay.
All right, 4 says find the indicated measure. Leave your answer in terms of pi. What are the same set of instructions, but we're looking for the total circumference of the circles. You want to walk me through it?
Yeah.
Go.
I know the diameter is 16.
Good. And either direction, right? Either top to bottom is 16 or the left to right all the way through both circles is 32. So they would both be 16 the other way too. Okay.
Well, we'll add it to.
If it's C or circumference equals pi times 16, and that's leave it in terms of pi.
Okay, so you're doing pi times diameter. So you did 16 pi. That would be one of the circles, right?
Yeah. Oh, yeah, it has to be of both.
It says total circumference of the circles. So times 2.
Times pi.
32 pi or?
Or it's 100.6.
Good.
I did 32 pi.
100.5
100.5.
centimeters.
Why is it 32?
Because there's 2 of them. It wanted both circles.
It says circle. It's 16 is the diameter.
You can if you go top to bottom, right? Then this way is the diameter, or left to right because it should make sense both ways. If it's 32, that means this would be 16 and this would be 16. Questions? All right, 5. Now you're finding the radius and you're given, and be careful when they give you a measurement along the outer edge and it's not in degrees. This is our length. So this time they gave me 42 is the length. The measure of the arc would be 110 over 360 times, I want radius, so 2 pi r. You can simplify this or you can start moving things, okay? Because it says keep in terms of pi, I'm going to start by simplifying. So I could do 2 into 360, that's 180. I could multiply both, well, I could actually get rid of the zeros. And I'd get 42 equals 11 over 18 times pi r. I could multiply both sides by 18 over 11 to get rid of that part.
Or we just use calculator.
Except that it says leave your answer in terms of pi and write your answer rounded. So if it just said write your answer rounded, I would have 100% just kept going with the calculator.
Give us a lot of D's on the quiz.
There's not a lot of anything, but there are both types, yes. So this is 756 over 11 equals pi r, and then I'd have to divide both sides by pi, so pi is going to go on the bottom. So r equals exact 756 over 11 pi. That would be the exact format. And then 756 divided by 11 times pi in parentheses, because I need it to be grouped. 21.8. Said round to the nearest tenth again? Yeah. So 21.9. If it had gone like directly from here and I had my calculator, which is most likely the type of question you'll get with this one, I would have multiplied both sides by 300 over 110, or 360, sorry, over 110. So I would do 42 times 360 divided by 110, and I get 137 point blah, 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 equals 2 pi r, and then I would divide both sides by 2 pi. Again, you got to group the 2 pi.
This Chris was
Yeah.
60.7 over 5.
So that is rounded. You can't do that. If it's kept exact, it has to be kept exact. If it's rounded, it should be that 21.9. You don't want to do 756 divided by 11 and then round it. That's now, it's not accurate anymore. It's not exact. So exact would have been this only, and rounded would have been this one. Good? Yeah? Okay. All right, this is 6. It says now we're finding the circumference. So you're given the length of the arc is 92.8. So I would do length equals the measure of the arc over 360 times circumference, because that's all I'm looking for. So the length is 92.8 equals the measure is 150 over 360, and then I'm just missing the circumference. So instead of doing 2 pi r and then having to multiply it back out, I could just leave it like that. I can cross through the zeros here, and then 3 goes into both those. That'd be 5/12 c equals 92.8. If I wanted to keep it exact, I'd multiply both sides by 12 over 5. And then I would do 92.8 times 12, 1113.6 over 5 would be your circumference. Rounded to the nearest decimal, 1, 2, 3, divided by 5 is 222.72. And it said, oh, on yours it says 10th, right? So it'd be 222.7. Questions? Questions on the homework that came up were these. This is 5. 5 gives you the arc length of the big arc LM. It's missing a point in between, but if it had a name. And it gives you that's 260. So if I want the radius, it would be 260 over 360 times 2 pi r equals 38.95. So then I can multiply by 36 over 260 to get rid of that part. Those are gone. And then I can divide by 2 pi. And you can do that as many steps as you want. 38.95 times 360 divided by 260 gives me 53.9307, so on. Divide that by 2 pi. Putting the 2 pi in parentheses so that it groups them together. And I get r is 8.58. So you got to work backwards. Yes, you will have questions like that. Yes, you will use your calculator. Okay, this is 7. It wants the perimeter about, what did it say? I cut it off. It wants the perimeter of the circle?
It just, that's all.
Oh, the whole thing. It wants the whole thing. So he wants the perimeter all the way around.
Okay. I thought it was just. I don't know if it's just.
Did it say? No, unless the direction said that. I don't think it did.
There were no directions.
All right, so it should have been shaded region. So it's here, 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 and here. So you have 6 plus 6 on that side, but then the other 2 parts are the arc length. So I have to find the arc length, and they're the same, so you could find one and double it. But the arc length there would be 90 over 360 times 2 times pi times 3, because that's the radius. So I would get 1/4 here. 2 goes into 4 twice. So it'd be 3 pi over 2 would be the arc length of one of those. Multiply it times 2. And my arc length of those 2 would be 3 pi. So together, this is 3 pi plus the 6 plus the 6. 3 pi plus 12 would be, if you kept it exact, 3 pi plus 12 is 21.42. I don't know what that's around to. Yeah, 42. So it was missing those sets of instructions. If this was something that like was asked of you, it should have said shaded region. Yeah.
Wait, how do you know that the length of the arc was 90?
The measure of the arc, because this is a right angle, and so those would be the same. That central.
But isn't like measuring degrees different from like the actual length?
Right, so the length is 3 pi over 2.
I'll try using that.
Right? It's the measure that you use in the formula.
I did it a different way, but I want to know if it'll like still work. Like,
What'd you do?
I used the 3 as the radius, so I did 3 equals 2 pi r. And then I found the circumference and then just did the measure of the arc over 360 times the circumference.
That's fine. Yeah. Yeah, because this part is interchangeable with circumference or pi d or 2 pi r. Yep. All right, then 8 said find the perimeter of the shaded region. So obviously that set of instructions was missing from the other one. That's what it should have said. So I need to find the perimeter all the way around here, okay, which involves the 5 plus the 5 plus the 5. That's the easy part. That's the 15. And then I need this arc length, and this arc length. They are all the same, so I can find one of those and multiply it times 3. The 120 would be the measure of the arc over 360 times 2 times pi. This whole thing is 5, which means this would be 2.5 and this would be 2.5, which would be the radius. Or you could have done pi d, which is 5 pi. Same thing. The 5 was like from one center to the other center. Yeah. Yep. So then I can do this. This would be 1/3 times 5 pi, or 5 pi over 3 plus 15. And then use your calculator. 5 pi. Divided by 3 plus 15. And it's 20. Wait. 5, 10, 15. Oh, I didn't multiply it times 3. Sorry, there's 3 of these times 3. So 5 pi plus 15.
Why is it 3? Oh,
50, this one's 5, this one's 5, and this one's 5. So the 3 parts of the circle were connected by those pieces. That's 30.71. Questions? That's a great standardized test question. Yeah. All right, so what we're going to do today is area of a circle, which we already know, and then area of a sector, which is like the area of the piece of the pie. There are going to be questions like these that apply that. Okay, you'll see one of them in the notes, but there will be stuff like this, and that kind of stuff would be on both homework and the quiz. Here we go. All right, 11.2, area of circles and sectors. So we start with the area of the circle, which is pi r squared, something you've used a lot of years. R stands for the radius. So we always square the radius, then multiply by pi. You cannot multiply and then square. The sector of a circle is the region bounded by 2 radii and their intercepted arc of the circle. So this is like a piece of the pie. If I wanted to find the area of the piece of the pie, piece of the pizza, whatever it is, that is called area of a sector. So this guy right here is the sector. which is a portion of your area. So we're going to find part of the area. Hold, please. So the area of the sector's formula, and it's just written there a couple different ways. It says, and this is, I wouldn't worry too much about all the way on the left, the measure of the arc times the area, well here, no, sorry. The measure of the arc times pi r squared. So just like we do the measure of the arc over 360 times the circumference to get the arc length, we would do the measure of the arc over 360 times the area of the circle to get the area of the sector. So that, I would say, is the part you want to memorize, not the left side. I think that's more confusing. It's just, that's what pi r squared is.
Oh.
No, you can use either one of those. So you can either use, like if it just said, let's just say it gave you the area of the circle, then you don't have to multiply out pi r squared, you would just use the area. All right, so example 1 says find the area of a circle with a radius of 4.5 meters. Leave answers in terms of pi and then also calculate using your calculator. So we're going to do both. So the area of the circle is pi r squared. Pi times 4.5 squared. 4.5 times 4.5. Is 20.25 pi meters squared, because it's area, would be 4.5 squared. Then if I actually use the pi button on the calculator, 20.25 times pi, we're going to round to the nearest tenth just to be consistent with the warm-up. You get 63.6 meters squared. So exact would be the one on the left. Rounded would be the one on the right. Mars.
If we don't put meters square on the quiz, are we gonna get points off?
No.
So you just do 20.25.
Pi. You can't forget pi, but yeah. B says find the radius of the circle with an area of 176.7. So if my area equals pi r squared and 176.7 is the area, how do I solve for r?
Square root.
Before you do that, because you can't square root the pi, right? I have to divide by pi first. I got to isolate the r squared. So r squared, we're going to keep it to the nearest tenth, would be 56.2. And then I square root. Because it's r squared. So then I square root. Would it be plus and minus? Why not?
Because you can't do mine. It can't be a thing.
Good, radius can't have a negative length.
What would it be if it asked for in terms of pi?
You'd have it underneath the square root. That won't happen. Like you'd have 176.7 over pi underneath your root.
But he asked it, what if you keep it in terms of?
Right, it would be the square root of 176.7 over pi. Most likely it will not ask for that. All right. Now it says the radius of the circle is 3 centimeters. Find the area of the sectors determined by the given arc. And leave your answers in terms of pi. It's really just 2. I just need to remember them. All right, remember, measure of the arc over 360 times pi r squared. So 50 over 360 times pi times 3 squared. So what you cannot do is do 3 into 360 yet. You have to square it first. So I can do 50 over 360 times pi times 9. Now I can cross through the zeros. 9 goes into 36 4 times, and I get 5 pi over 4. All right, B is 20 degrees. So 20 goes over 360 times pi, radius is still 3, squared. Cross through the zeros. 2 goes into 36 18 times. And then 3 squared becomes 9. And 9 goes into 18 2 times. I have nothing left in the numerator besides that pi, so it's just pi over 2. repeat that thing again for C. 140 over 360 times pi. We know r squared is now 9. The zeros cancel. What goes into both 14 and 36?
3.
2, this would be 7 and 18.
I think you should take out the zeros.
I did take out the zeros. And then 9 goes into 18 twice.
Because 9 times 2 is 18. Yep.
I crossed through the zeros. And then I had 14 over 36, and I put 2 into each. Yeah, you could go in any order you want. Like I could have gone 9 into 36 would be 4, and then you'd have 14 over 4, which is still 7 pi over 2.
How'd you get
It's actually a better question.
So I crossed through the zeros on 20 over 36, right? And then I did 2 into 36.
Oh, so you got 1 over.
So
It'd be 1 over 18, and then 3 squared is 9, and 9 goes into 18 2 times. So you can go top, you can cancel top to bottom and diagonal. Mars.
is pi always going to be in the numerator?
Usually, yes. Unless it says to not leave it in terms of pi, then you'd multiply it out. All right, 210 over 360 times pi, r squared is 9. Cross through the zeros. I can go 9 into 36 4 times, and then 21 pi over 4. All of them would have been in centimeters squared if it asked me for the unit. Everybody good? All right, this one says, find the area of the region bounded by segment AB and arc AB. So if it had said shaded region, it would have looked like this.
It's not freaking shaded.
How do I find it?
Find the area region bounded by a segment AB. So we have 120.
You have the angle here, yeah, 120, which would be the same as the measure of the arc.
120 over 6 is the radius.
6 is the radius.
Times
It's a triangle, so we could find the area of the
6
triangle.
squared.
So you could find the area of the whole sector, right? I'm going to find the area of the whole sector and then subtract from it the area of the triangle. Good. So area of the sector first minus the area of the triangle. So the sector would be 120 over 360 times pi
I have the answer.
r, which is 6 squared, which is 36. I could cross through the zeros here. 36's cancel, and this is 12 pi. So the area of the sector is 12 pi. How do you find the area of that triangle?
Good question.
A and B. We need to find the height.
I do have to find the height.
Is this going to be on the quiz?
You're going to have application questions on the quiz, maybe not this exact one, but what happened to that 120 when I drew that?
Split in half.
Split it in half, which made it
60, 30, 90.
60, 30, 90 triangles. So if the hypotenuse, remember your 30, 60, 90. So if I just drew one of them, 30, 60, 90. Opposite the 30 is A. Opposite the 90, 2A. So if 6 is 2A, what's the height of this triangle?
No, we already.
3. What's the opposite the 60? 3 root 3. So this is 3 root 3. The whole base. So now how do I find the area of that triangle? 1/2 base times height. What's the base?
6 root 3.
6 root 3. What's the height?
3.
3. 1/2 of 6 is 3, and 3 times 3 is 9. root 3. So actually left exact would be that answer. That whole big yucky thing. I love you. Goodbye.
How do we get to find the triangle?
Because you have to find just the area of the shaded region, that pink shaded region.
I thought the chapter.
The sector is 12 pi.
6 root 3 would be opposite the 60 times 2.
The chapter is called area of circles and sectors,
That is correct. The section, you mean? The
not finding triangles.
it's like you haven't realized so far that in geometry everything is cumulative.
Wait. Oh, that's 6.
What's 6 root 3? How'd you get it?
So on the small triangle, on half of the triangle, right? That small triangle would be this one. It'd be a 30, 60, 90 triangle. Opposite 30 is A. Opposite the 60 is A root 3. Opposite the 90 is 2A. And that's the one you have. So then the A is 3, and the opposite 60 is 6 root 3. It goes back to your 30, 60, 90 triangles. So it looks like this initially. Guys, shh. And you only have that side.
And then, but how'd you get
So
the-
this is A, this is 2A, this is A root 3.
how'd you get the- Oh,
So A is 3, right? Which makes the height of the triangle that, and the base of that big triangle is 3 root 3. That's only from here to here.
okay.
So then I double it to get the base of that big triangle.
Oh, so the root 3, so you double it, and you get 6 root 3. and
Yeah.
you divide.
So there are going to be shapes in which you have to be, like, apply the prior knowledge. It's going to happen on homework too. There's going to be ones that say area of shaded things where you have to find the area of something big and subtract from it something smaller. Okay, there's gonna be a lot of application on that kind of stuff, and there will be stuff like that on the quiz.
Like this? Like this?
Not this exact one, but there is stuff where you have to find the area of something shaded.
Oh, Sophia,